So, hi guys, this is Dr. Edwards again. I want to give you some suggestions on the third assignment. This is an assignment from chapter 10, exercise problems 41, 44, 49, 51, and 52. So for problem 41, the question is, what is the charge on alkali metal ions and on the halogen ions and on the oxygen ions? So hold for a moment. Let me flip to the periodic table. Um, One moment. Okay, I'll just go this way. Um, Hydrogen is in group one of the periodic table. And so so all of the alkali metals are in group one of the periodic table, except for hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. And the charge on those is a positive one. So all the alkaline metals uh, have a positive charge. One, during a chemical process, these metals lose the electron, and therefore they will have a charge of one. Let me go over here. Now, next in the list was what is the charge on the halogen? The halogens are in group 7 of the periodic table: fluorine, chlorine, bromide, iodine, and astatine. Since they lack one electron from having a full outer shell, or the charge on them when an electron is transferred to these atoms, all of the halogens, it will have a charge of a negative one. Okay, so the halogens have a charge of a negative one. Oxygen now sits right here. It's in group 6 of the periodic table. Oxygen has 6 electrons in its outer shell. 1, 2, 3, 4, 5, 6. 6 electrons in its outer shell, and would like to receive 2 in order to have a completed shell similar to neon. Therefore, oxygen has a negative 2 uh, uh, charge on it. Okay, so that answers those questions there for number 41. What is the charge on the alkali metal ions, on the halogens, and on the oxygen ions? Okay, let me go back. The second question is 44. How many atoms of which elements are present in a molecule of C3 H22 chlorine? And this molecule happens to be chloroethane. And what you do, you go from left to right, if you will, and you examine each atom that's present. If there's no subscript at the bottom of a symbol for an atom, that is one. So chlorine, I see, has one electron of carbon is present, not chlorine, carbon. C for carbon. So there's one carbon atom present there. There's 3 hydrogens present here. Now this has the subscript 2 outside the parentheses address the carbon inside and the hydrogen inside. So there are 2 carbons here. And there are 4 hydrogens here. And now there's one chlorine atom. So what do you see then? Here then I see then that uh, there are 3 carbons, there are 3 plus 4 hydrogens, so there are 7 hydrogens and 1 chlorine atom in this molecule. So that's the way it goes always. It is, you count the subscripts. Now, if you have a coefficient, say suppose there was a 2 in front of this carbon, then that coefficient multiplies each subscript through. Okay, all right, so that answers 44. 44, once again, I see a total of 3 carbon atoms. I see a total of 7 hydrogen atoms, and I see 1 chlorine atom. Let's see what's the next one is 49. Which of the following equations are balanced? As we've said, balance simply means you must have the same number of each type atom in a different distribution, perhaps, on the left-hand side of the equal sign for a chemical equation as opposed to the right-hand side. So we have zinc plus sulfuric acid yields then hydrogen gas and zinc sulfide. Now look here, firstly I see only one atom of zinc on the left-hand side, 1 atom of zinc on the right-hand side. So zinc is balanced. I see 2 atoms of hydrogen on the left-hand side. I see 2 atoms of hydrogen on the right-hand side. So hydrogen is balanced. I see 1 atom of sulfur on the left-hand side, and I see 1 atom of sulfur on the right-hand side. So sulfur is balanced. I see 1 atom of 4 atom of oxygen and 4 atom of oxygen. So the first equation is completely balanced. Come to the second equation. Right away, I have aluminum here, and 3 times oxygen gas will yield then aluminum oxide, but there's only 1 atom of aluminum on the left-hand side and 2 atoms of aluminum on the right-hand side. So then B is not balanced. A is balanced, B is not balanced. Come to C, and what you see here in this particular case is carbonic acid, H2CO3, and supposedly yield H2O and CO2. Come back now. Firstly, I see 2 atoms of hydrogen here, and I see 2 atoms of hydrogen on the right-hand side. So hydrogen is balanced. I see 1 atom of carbon on the left-hand side, 1 atom of carbon on the right-hand side, so carbon is also balanced. I see 3 atoms of oxygen on the left-hand side. I see 1 atom of oxygen in the first compound on the right-hand side, and 2 in the second compound, a total of 3. So therefore, everything is balanced. So now, therefore, C is also balanced. So A is balanced, C is balanced as well. What about D? I see now this coefficient 3, as I said earlier, multiplies each element that follows it. So I see 3 carbons on the left-hand side. I see 3 carbons on the right-hand side. I see 3 oxygen in the first compound on the right-hand side. On the left-hand side. And I see 3 in the second compound, this iron 3 oxide. So that's a total of 6 on the left-hand side. There's a total of 6, 3 times 2 on the right-hand side. So oxygen is balanced. For iron, I see 2 iron atoms on the left-hand side. There are 2 iron atoms on the right-hand side. So that too is balanced. So what we have here, A is balanced, C is balanced, D is balanced, B is not. Give a reason for why when you write this up as I said to you. Okay, let's go to the next one, 51. 51, insert the missing number in the following equation. So what one has to do now is to ascertain what you need to make a balanced situation. So right away, I see 1 atom of calcium on the left-hand side, 1 atom of calcium on the right-hand side, and that's no problem. But come here for hydrogen. Here I see possibly a coefficient needs to be in front of the water molecule. I see H2. So I only see 2 so far. But on the right-hand side, I immediately see 2 hydrogens in the first compound. I see 2 hydrogens in the second molecule. So there's a total of 4 hydrogens on the right-hand side. I must have a 2 because 2 times 2 would be 4 on the left-hand side. So that 2 also addressed this oxygen. So therefore I will have two atoms of oxygen on the left-hand side and 2 atoms on the right. So the insertion of 2 will balance the equation. Therefore 2 needs to be inserted for A. Let's look at B. What's in front of the hydrogen sulfide? Right here I see 2 atoms of hydrogen already, but I need to have a total of 6. Therefore, I need to have possibly a 3. 3 times 2 would give me 6. So I put a 3 there. Then hydrogen will be balanced. Sulfur will be balanced because sulfur has 3 on the right-hand side. 3 times 4 will be 12. 3 times 12, 4 is 12, so oxygen is balanced. So everything will be balanced if I were to put, what did I say? Put a 3 here, okay? Let's go to C. What is the situation here? Come here, I see 16 hydrogen on the left-hand side, and I only see 2 so far on the right-hand side. So I need to put an 8 in front of that because 8 times 2 is 16. Then that would be hydrogen will be balanced. Inquire as to whether oxygen will be balanced. So that would be, I see 2 oxygens there in this. Oh, there is a printing error here. That should be a plus sign where that first yield sign is. That should be a plus sign. So I see then a total of 22 oxygens there. 7 times 2, 14, plus what I would have there, 8. So that would be balanced, okay? So we need to put 8 needs to go in there. What about the next one? We have a situation where this quantity breaks down. I see 6 hydrogens there. I see 4 on this side, and I need to have a total, I see 18 hydrogens. 3 times 6, 18 hydrogens. And there are only 4 there. So 4 from 18 minus 4 will give me then 14. So I need to put a 7. So 7 needs to go in there. Check out the oxygen. If you put a 7 there, I would have 7 oxygen there plus 11, 18. And so I'll have oxygen is balanced. Okay, let's go to the last one, 52, and we'll do some parts of that because I'm almost running out of time. So let's just do the first one. What is the missing situation here? In the first one, 2 hydrogens are represented there, but in A, I have 12 hydrogens on the left-hand side. I must have 12 on the right-hand side. The way to get 12 is to put a 6 there. So A for 52 has to be a 6. Let's do B, and then you finish the others as I've done here. I see 4 nitrogens on the left-hand side. I see 4 nitrogens on the right-hand side. For hydrogen, I see 12 hydrogens on the left-hand side